I like that. I like this a lot. I feel like this is better. I can move. I feel it. Yes. Good morning, gang. Today I was just thinking about certain topics I would like to discuss about. And one of them I was like, oh, why don't I just continue this engineering theme a little bit and talk a bit more about it? Because why not? And today it's going to be a bit longer. I'm not going to do 3 minutes, even though my internet at the moment is garbage. Australia, love it. NBN. But I was talking about what engineers actually do. So I'm an electrical engineer. I'm currently working for a company, Horizon, which handles the Central Queensland Network rail. And I'm actually considered in the below rail, so I handle the tracks to make sure that the trains can keep moving. That's basically the whole point. I'm just gonna, no, I should be right. So, what do engineers do? I always consider it into three categories because people always point at a building and go like, that was through engineering. Or they point at the road and go, that is engineering. Or like, just general stuff. And I'm like, hold up, not really, no. So I consider into three categories. There's design, there's logistics, and then there's maintenance. So engineering, anybody can do it. It's just a way of life, basically. So some people consider it like the connection between the academic and the real world applications. So it's using the theoretical mathematics and applying it to real life objects. So we have forces, we have gravity, we have all these complicated formulas that just remove things for the sake of trying to prove them correct. Such as like some points in time we can remove with gravity, we probably just ignored air resistance and just said 9.81 meters per second. Or we've got Ohm's law, which is what I use as an electrical engineer, and we just ignore conductivity, thickness, and metallurgy, and also the angles of wires, the frequency, high voltage, and we start getting more and more complicated. However, we put it down to very simple devices so that we can apply it, basically, and then hopefully we can consider it and make some assumptions to extend our points of safety. Safety, sometimes it's purely just so that the wire doesn't melt, and decrease costs, which always comes into play. So that's mostly design. Design, I consider the point where they meet the theoretical, you got the theoretical, and then you got the real life. So now any person can draw up a drawing of a good chair. Everyone can think of a good chair. Now let's say you wanted that chair really strong. What do you normally do? Add on some more material onto it. Add some stronger material to it. Make it out of tungsten steel, carbon fiber. Make that shit strong as shit. And what do you do then? So that means that the chair is stronger. You've achieved your goal. However, the price is insane for just a simple chair that's just strong. It's pretty basic. So imagine doing that to a humongous crane that's probably like, 100 meters in the air. How would you make that stronger? And that's where the design team comes in. And they go, okay, how do we make this stronger at the cheapest price possible? And they will start looking at stuff and they'll start designing it and seeing where the forces act upon each part, analyzing it using computer software, using just general engineering knowledge. And that's the importance of design. With the electrical side, it's like which component can fit into this, which one does the job it's necessary. Let's say like you're trying to make it so that three-phase power turns into DC power. You would need to use like many different components to make it so that you split the three-phase into a single phase and change it from AC to DC, and you want it to make sure that the DC is the correct DC voltage and amperage so that you don't break anything. And then you've got to consider like frequencies and wires. And so that's where design comes in. And design's where most of the math is in engineering. If you really just enjoy mathematics, you'd hope to be in design. The next one is logistics or project management, or just roles and positions where you consider mostly just pure costs. In the first place, you probably have a team of engineers and you are contacting people and getting manufacturers and calling up being like, hey mate, can you get this piece of material to my doorstep yesterday? No, usually it's not like that. Engineers aren't. Some of them are pretty cool. Most of the design team, they have a bit of a stereotype going where they're just sitting at the computer hunched over, and then you got the project managers who are just like, they're just, let's go. No. So when it comes to those, yeah, it's purely just cost for them. They'll have Gantt charts, they'll have project times, they'll have finishes. They'll usually contact the stakeholders, which are people that are buying it, the customers, and they'll get the scope down pat. They'll be the ones that go like, okay, you need this, this, this. They'll ask questions. They'll get every single detail correct so that the design team doesn't even have to contact the stakeholders. They will have to be in the meeting, of course, but they will have a list of questions that need to be answered so that everything is correct and on point. Because otherwise, like, you'll end up wasting money, wasting time, wasting potentials. And the conversation needs to happen, and that's usually where those people lie. And they're pretty rare because you need some good communication skills, which can be hard to find in engineering, purely because like most of them find that they like the computer side of things. They just purely like to handle their own field. They're very focused, very focused. And then we got the last one, which is maintenance. Maintenance usually is just safety. They're the people that will be the ones that maintain, and they'll keep things going. So bridges, we've got tons of those. Buildings, they'll inspect them and see what needs to be improved upon. They'll take it to the design team. The design team might make improvements. Or it'll just simply being them being like, okay, this needs to be reinforced. This is falling apart. Let's get that back in order. And so when it comes down to it, most engineers will flip between these three roles. So they might end up at one point just designing an electrical board, and they might end up having to go to a similar electrical board out in the field and be like, okay, this needs to be maintained better. We need to either A, swap it out, or try to improve it, or remove a part and put it back in. Usually, depending on the company, in electricity, it's just replace. With me, mechanics, it's kind of like slap some grease on it. I have no idea. There's a bit of rivalry with the electrical, civil, and mechanical sides of things. Mechatronics is kind of like out the door. But overall, that's usually how my personal opinion, feature engineering. And we put that to a higher degree. So most of the time it'll be from usually people are dealing with tens of dollars or hundreds of dollars when it comes to their own little projects at home. With engineers, it's when things start getting to the millions of dollars and upwards, of course, and hundreds of thousands of dollars that we need people to be like, okay, hey, let's not waste money here. Let's not waste resources. Let's not waste time. Like, let's get this thing going, and we make sure that everything's to the scale and efficiency, and what's the expectations, what can we achieve? And these are the questions we will ask in the scope. And so that needs to be explained and expanded upon, and stakeholders need to be informed, and it becomes quite a big position. And that's why usually engineers are put into that role after probably like 10 or 5 years of experience before they're actually able to do that. Some of them are younger. Myself, I am currently just Excel spreadsheets, data analysis, data management, all the good stuff, frankly, at the moment. So nothing impressive to tell. But we'll be climbing, hopefully, up in the ranks with time. But yeah, there's not much math once you start getting upwards. Of course, you will need to know basic theories and stuff, but design's where it's at if you want the maths. If you like communications, you're very rare, and you're doing engineering, very rare. No, they're not rare. They're there. They just need to practice. And then maintenance, that will be incredibly important in the future. We underpay those that maintain our infrastructure. So we will need more engineers for that. So I hope this helps any person in their engineering degree in understanding what your roles will be, hopefully in the future. And we will need you in the future. I think Australia is looking at, we need 100,000 engineers in the future just to maintain our bridges and roads. So if you can join the STEM team, get it going. Anyway, I'll be seeing you in the morning, gang. See ya.